How many degrees are in a triangle? Cool. How many degrees are in a circle? All right, cool. Good start. Good start. Show me with like your hands or like, yeah, with your hands like this or something like that. You can use your arms. What's 60 degrees look like? Okay. You are all correct, but you're all different. Okay? Somebody is using your hands like this, and you're like, boom, that's 60 degrees. And then some of you are like over here, and you're like, that's 60 degrees. And some of you are like, oh, it looks like that. Like, you're all correct. These are all 60 degrees, but you're all different, okay? We're going to focus on angle measurement a lot here. The first thing we want to do is get you all pointing in the same direction, okay? Cool? So we are going to introduce what's called a standard position of an angle. And that is the first thing we are going to learn that is new to you, a standard position of the angle, okay? And we are actually going to think about being on the x-axis and the y-axis. So this is a y-axis. This is an x-axis. And here's how I like to think about it, but then we'll use our hands to kind of pretend this is going on. Pretend your head is at the origin. And you are looking off to the right towards the positive x-axis. Or everybody take your hands, point them in that direction, the positive x direction. Put them together. That's 0. This is our start, okay? Now, for everybody's 60 degrees to be the same, we will keep our initial ray on the x-axis. This is called an initial ray. This is like the start of our angle. If we put our terminal ray, our ending ray, on top of our initial ray on the x-axis, that's an angle of 0. If our terminal ray goes counterclockwise, we are adding to our angle. Now, please everybody give me 60 degrees in standard position using your hands. It all should be the same, no matter who I'm looking at. Do it, you know? Get that, okay? It should all be over there, up 60 degrees. We all should be doing the same thing instead of, oh, okay? Cool. So, where's 90 degrees? Use your hands, go, 90 degrees. Good. Starting here, everybody's 90 degrees is the same. Not some people are going like this, some people like this. Everybody's 90 degrees the same. We have a standard position of 90 degrees. What's 180 degrees? It's all the same. Now you're not like, oh, that's 180 degrees. Oh, straight up and down is 180 degrees. You're all like, we're starting at 0, standard position, 180 degrees. It can keep going. Where is 210 degrees? Now it should all look the same, but tell your neighbors, like, where is it? Where's 210 degrees? Where's 210 degrees? Here's 0, Jolly. Here's 90. Here's 180. Where's 210? 30 degrees more. Oh, this is interesting. You guys aren't used to angles that are bigger than 180. Guess what? They exist. If you go halfway around your circle, you're at 180 degrees. If you want to continue to add, you would continue to move your hand in a counterclockwise position. Here is 0. Here is 90. Here's 180. I can keep going. This angle is 270. It's 30 degrees away from 180. That's how I'm going to find it. I could keep going around. This angle, what would that be? What's this angle? Yeah, it's the same location as 0, only my arm has gone all the way around. That's 360. Okay? This is a standard position of an angle. Okay, everybody, let's try this again. Where is 150? Where's 150? Now, be specific. Tell your neighbors, like, where exactly is 150? Okay, this is very important what you are saying. You are all using what is called a reference angle. This 30 degrees is called a reference angle. This obtuse angle is 150 degrees, and that's important, sure. But what's actually more important for the rest of this unit and for the rest of the semester is the fact that 150 degrees is 30 degrees away from 180. The reference angle is actually more important than the obtuse angle. Reference angle as in reference to the x-axis. Where's 330? Tell your neighbors, or draw 330 over here. What does 330 look like? And then tell your neighbors, where exactly is 330? Where's 330? Good. I would say it's 30 degrees away from 360. Ready? I would go all the way around, but I would stop 30 degrees away from 360. So I would say that 330 has a terminal ray here. The terminal ray is 30 degrees less than 360. I'd say angle AOC, which is 150 degrees, is really just 180 degrees minus 30 degrees. I'd say angle AOD, which is 330 degrees, is really 360 degrees minus 30 degrees, to be specific. Where's 225? Where's 225? Draw it. Where's 225? You have to do a little bit of math, maybe. Where's 225? Where's 225? Where's 225? Angle AOE. I'll call this E. Going in standard position this way, 225 is 45 degrees more than 180. Cool? What about AOB? Where's 120 degrees? Now, ready? This is the most important one. AOB, I'm going to say, is 120 degrees. Many of you are going to be saying it's 30 degrees away from 90. You are correct. You are correct, and that's fine. However, for the purposes of the future of this unit and the future of this semester, I would like you to say that angle AOB has a reference angle of 60 degrees from the x-axis. This reference angle is the most important part of the rest of this unit. Not the y-axis. A reference angle is the angle created reference to the x-axis. AOB, I would say, is 60 degrees less than 180. Cool? Cool. Where's the x-axis? It's either 0, 180, or 360. But there's a problem. I talked to an alien the other day, and I was talking to him about 360 degrees in a circle, and he's like, I have no idea what you're talking about. And I was like, oh, geez, you're right, Mr. Alien. 360 degrees is a number made up by human beings. It is not something that's universal that this alien could understand. Why are there 360 degrees in a circle? Does anybody know? Do you know why why aren't there 100 degrees in a circle? Why did we decide to use 360 degrees in a circle? Why didn't we say this was 100? I'll give you some hints. There is something in this world that human beings experience that is very close to being 360 and involves making a circle. That does? Each degree being a day and days in a year. If we start today, about 360 days from now, we'll be back in the same location with the sun located in the same exact spot. Now, let me ask you, the alien that I met, do you think his planet's orbit is 360 days or approximately thereof? Probably not. It could be more or less depending on how far it is from its sun, which could be bigger than or smaller than our sun. 360, made up by us because we live on Earth, and our Earth's rotation takes, or Earth's revolution takes 360 days. Back in the day, human beings were like, yo, this must be the number for a year. And then they realized that it wasn't, and it was 365, and they're like, well, we're going to keep 360, and for 5 days we're just going to party, and then we'll start over. Literally, like, their year was 360 days, and the 5 days are like the extra ones that the gods gave us. And we just partied for 5 days, and then we're like, okay, now we're going to restart. 360 being a very important number. Why? If you take 360 and divide it evenly by so many different numbers, 180, 90, you could split it into thirds, into fourths, into fifths, into sixths. You can't split it into sevenths. But boom, because the alien didn't know about 360, we needed to connect about circles some other way. So, what did we connect with? The concept of a circle and with a radian. Guys, we're not using degrees, but we need to keep them in our brains. They're going to be useful, but instead of degrees, something that's universal is radian. Now, here's my definition of a radian. I want you to write down. A radian is a distance, or like an arc length, around a unit circle. Okay. Board. First thing is first. The most important thing, honestly, for the rest of the year is this idea of a unit circle. A unit circle is called a unit circle because its radius is 1. Okay? That's a unit circle. Now, you guys remember from geometry the formula for the distance around a circle. What is the formula for the distance around a circle? There's a special math word for distance around a circle. I'm not going to tell you what it is. You guys are going to tell your neighbors what it is, and you're going to tell me what the formula is. Okay. We're not squaring. It's just 2 pi r. Okay? The circumference around a circle is 2 pi r. What is the circumference or the distance around a unit circle? Archer. If this is the circumference of any circle, what's the circumference of a unit circle that has a radius of 1? Good. Guess what? Circumference of a unit circle, 2 pi, which means if you have a circle with radius of 1 and you go all the way around your circle, 360 degrees, which you're comfortable with, you're going to have to equate to being 2 pi radians. They're equivalent. Your understanding of 360 degrees is equivalent to a universal understanding of 2 pi radians, this distance around the unit circle. 2 pi is all the way around the circle. It is the circumference of a circle. We say 2 pi radians is equivalent to 360 degrees. What if I go halfway around my circle? What is half of the circumference of a unit circle? Tell your neighbors. Pi. If 2 pi is around the whole circle, 1 pi, 2 pi divided by 2, is equal to 180 degrees. What would be equivalent to a quarter of a circle? Tell your neighbors what would be equivalent to 90 degrees in terms of a distance around a unit circle. What's a quarter of your overall circumference? 1/2 pi or pi over 2. We'll write it as pi over 2. That's how you're going to see it. If you wrote 1/2 pi, good, you understand things. It's either taking 2 pi and dividing it by 4, or it's taking pi and dividing it by 2. Cool. So, we're still starting at 0. 0 degrees is equivalent to a distance of 0 radians around the arc of this unit circle. Great. Now, let's find some other interesting radian measurements. For example, let's look at radian measurements whose reference is 45 degrees. Now, that means we're talking about this angle, 45 degrees away from the x-axis. This angle, 45 degrees away from the x-axis. This angle in the third quadrant, 45 degrees away from the x-axis. And this angle in the fourth quadrant, 45 degrees away from the x-axis. Keeping in our brains that the angle measurement 360 degrees is equivalent to the circumference of 2 pi around the unit circle, and that 180 degrees is equivalent to the arc length or the circumference of pi, like half of the circumference, and that 90 is equivalent to pi divided by 2. What's 45 equal to? Tell your neighbors. What would 45 be equal to? This is important. This is brand new for all of you, so keep your minds open and try. Pi divided by 4, you nailed it. Okay, great. Pi divided by 4. A pi over 4 arc length is equivalent to 45 degrees. Pi over 4 arc length of a circle radius 1. Great. So, in the first quadrant, this 45 degree reference angle is equivalent to this arc length of pi over 4 radians. 45 degrees, pi over 4 equivalent. Okay. Now, this angle in the second quadrant. which is 135 degrees. How do I know it's 135 degrees? Well, I did the calculation, and this is very important. 180 minus 45. I use 180, and I know that going around in a counterclockwise direction is like subtracting. I do 180 minus 45, and I get 135. Great, great. But the alien doesn't understand why we're using 360. The alien doesn't like this. So I change it. We talk about lengths around our unit circle. 180 is the same as pi. I got pi here. And instead of subtracting 45 degrees, I'm like, oh, the arc length equivalent to that 45 degrees around the unit circle is pi over 4. What's pi minus pi over 4? Pause, think about it. Some of you have it right away. Many of you don't. Hold on. Let me help you out here. This is important. This looks complicated, but it's not. What is 1 minus 1/4? Do that. What's 1 minus a fourth? Figure that out. What's 1 minus a fourth? Good. You turned 1 into 4 fourths. And 4 fourths minus 1/4 is 3 fourths. Well, you could turn pi into 4 pi over 4s. What's 4 pi over 4 minus 1 pi over 4? 3 pi over 4. We found that this angle, which is 135 degrees, which is 180 degrees minus 45 degrees, which is important, is the same as pi minus pi over 4. Boom, I got 3 pi over 4. I'm not going to memorize this. I'm going to understand how to get it. So, tell your neighbors, what's this angle in the third quadrant in terms of its radian measurements? That is 45 degrees more than 180. Tell your neighbors. It's 225, sure, I don't care. I want you to talk to your alien. What is that equivalent to? This is new, you better jump on in, the water's fine. A lot of you are not used to learning new stuff because the entire first semester was not new stuff. So if you are not used to acquiring content during a lesson, start. Who's gotten it? Anybody? Nice, Archer. Nice, Blanchard. Nice, Smollett. We got pi plus pi over 4. What's that? Well, it's just like 1 plus 1/4. That's 5 fourths, or 5 pi over 4. That's 5 pi over 4. Could you tell me what this one is? Now, I'm actually going to lead you for this one because there's a couple ways to do it. This is the way I'd want you to do it. I would want you to use the reference angle, Lazara. And I'd use the reference angle, which is the reference to the x-axis. I would go around my entire circle, and I'd go to 360 degrees, and I would subtract 45 degrees. Going in a clockwise direction is subtracting. Going in a counterclockwise direction is adding. This is very important. And I'll repeat it the next one. 360 is equivalent to 2 pi. 45 degrees is just pi over 4. 2 pi minus pi over 4, that's like 2 minus a fourth. Well, 2 is 8 fourths. 2 pi is 8 pi over 4. Minus a pi over 4 is 7 pi over 4. Got it? So, again, counterclockwise, starting at 0, adding, clockwise, subtracting. We did it with angles, we can do it with radians. Remembering 180 degrees is pi. What's 30 degrees equivalent to? $180 divided by what is 30? Tell your neighbors. 180 divided by what is 30? 18 divided by what is 3? 18 divided by 6 is 3. 180 divided by 6 is 30. Pi divided by 6 is pi over 6. Pi over 6 is equal to 30 degrees. This is the second angle that you're just going to know. Either you know how to get it or it just becomes something that's known. Now let's look at this. 45 degrees is what? Pi over what? What was it? 45 degrees is pi over what? 4. Write that down again. 45 degrees is pi over 4. Divide by a bigger number. This is a smaller fraction. It's equivalent to a smaller angle. Got it? Okay, now let's find the radian equivalencies of the angles that are 30 degrees away from the x-axis. Starting with our first quadrant angle of 30 degrees. What's that equivalent to? Tell your neighbors. What is it? Write it down. What is this angle that's 30 degrees away in the first quadrant? It's 30 degrees more than 0. It's pi over 6. Pi over 6 is 30 degrees. Okay. I'm going to do the next one. You guys do the last two. In the second quadrant, we have an angle that's 30 degrees less than 180. Going clockwise, we're subtracting. 180 minus 30 is 150. Cool. Change that into pi. Pi radians minus pi over 6 is what? What's 1 minus a 6? What's 1 minus a 6? Tell your neighbors what 1 minus a 6 is. 6, 6. Minus a 6 is 5, 6. 6 pi over 6 minus a pi over 6 is 5 pi over 6. This 150 degree angle is equivalent to an arc length or a radian measurement of 5 pi over 6. Do the last two. Go. Do the last two. Go. Tell your neighbors. What are the last two? What is this radian measurement in the third quadrant that is 30 degrees more than 180? Got this? Very important. Counterclockwise, adding angles. Clockwise, subtracting angles. What?
Oh my gosh, he actually was
Nice. What is this? What is this? What is this garbage? What is this garbage? Throw this out. What is this? We don't do it that way. Because if you do it that way, you don't really understand anything. Where'd you get that from? That's memory. It's not understanding. Okay? So we're not going to memorize it. Okay, great. This is 7 pi over 6. Why? Because it's the same as 180 plus 30, which is pi plus pi over 6. That's 7 pi over 6. This one, 30 degrees away, is like 360 minus 30. You could say it's 0 minus 30. And you'd be correct in thinking, could we have a negative angle? Yes, we will have negative angles eventually. But for right now, don't worry about it. We're going to go all the way around to 360. Then we will subtract 30 degrees. We will go all the way around to 2 pi in terms of our circumference. We will subtract a pi over 6. It's like 2 minus 1/6. That's 12/6 minus 1/6. That's 11 pi over 6. Hold on. We're not done with this page yet. What's 60 degrees equivalent to? 180 divided by what is 60? Barry, what's 180 divided by, well, what do we divide into 180 to get 60? Yeah, 180 divided by what is 60? What? Got you. I know, because you're not paying attention. 180 divided by what is 60? Come on, everybody. What? 3. That means pi over 3 is the third and final one that we have to just know. Now, let's look at this. Let's look at this. We can order these. Dividing by the least number, dividing by the greatest number. This will be the largest fraction when I do the division. Pi divided by 3 is going to be bigger than pi divided by 4, which is bigger than pi divided by 6. Biggest fraction, biggest angle. Divide by 3 produces a bigger angle than dividing by 6. A lot of students mess these two up, but don't. Pi divided by 6 is dividing by more things, giving us a smaller angle or a smaller arc length. Pi over 3. Now, could you guys give me the 4 radian measurements that are 60 degrees away from the x-axis? Go. Good. In the first quadrant, adding 60 degrees to 0 is just adding pi over 3 to 0 radians. In the second quadrant, subtracting 60 degrees from 180. 180 minus 60 is like pi minus pi over 3. What's 1 minus a third? 1 minus a third is 2/3. Pi minus pi over 3 is 2 pi over 3. Here, I would do 180 plus 60 to get this radian measurement. That's pi plus pi over 3. Pi plus pi over 3 is like 1 plus a third. What's 1 plus a third? 4/3, so pi plus pi over 3 is 4 pi over 3. You could change pi into 3 pi over 3. This, in the fourth quadrant, 60 degrees away from the x-axis, is like going all the way around to 360, but subtracting 60 degrees. That's like 2 pi minus pi over 3. What's 2 pi minus pi over 3? What's the fourth quadrant angle? Good. It's like 2 minus a third. It's like 6/3 minus a third, which is 5/3. It's like 6 pi over 3 minus a pi over 3, which is 5 pi over 3. Okay. Pretend we didn't do that. Pretend that you are not allowed to ever look back on something that you've already created or was created for you. On the next page, draw the terminal side and give me the reference angle to Here we go, here we go, here we go. Could you do it? Can you do it? Can you do it? 7 pi over 6. Where is 7 pi over 6? Don't look back at what you've already done. Where is 7 pi over 6? Where is 7 pi over 6? I'm going to start with just that, and then I'll help you if you don't know where it is. Draw the reference angle or write down the reference angle so that you know. Perfect. So that minus that is not going to give me 7 pi over 6. That's 7 pi over 4. But I like what you did there, Matt. That's going to help you in the future. Turn it into 60. All right, here's what's going to help you. The following. Pi 180, 2 pi 360. Pi over 6, dividing by the biggest thing, smallest angle. Pi over 4, 45. Pi over 3, 60. I'm going to focus on pi over 6, because it's 7 pi over 6. Now, here's what's important. It's going to be a pi over 6 away from pi or 2 pi. Seven pi over 6 is 1 pi over 6 away from 6 pi over 6. 6 pi over 6 plus a pi over 6. 6 pi over 6 plus a pi over 6 puts me in the third quadrant, 30 degrees away from the x-axis. Now, your other option was 7 pi over 6 being 12 pi over 6 minus, and you should have immediately been like, no, that's not. You know, you kind of figure out that pi is either 6 pi over 6 or 12 pi over 6. You know it's a pi over 6 away from that. All right, next one. Where is pi over 3? Where's pi over 3? Don't look back at what we already done. If you dare look back at what we already done, where's pi over 3? Where's pi over 3? That's right. What's the reference angle? No. It's always referencing the x-axis. Oh, okay. Okay. I like what you did, but eventually we're going to just like forget about the degrees. Okay? But I like what you did. Now, guys, the fact that this is equivalent to 300 degrees is actually not important. The most important thing, and you got to trust me on this, is the reference angle for the future of your pre-calculus lives. Believe me, the most important thing is to know that 5 pi over 3 is located in the fourth quadrant and it's 60 degrees away from the x-axis. That's the most important thing. What do? I do 6 pi over 3 minus a pi over 3. I go all the way around to 360 degrees and I subtract 60 degrees. I know pi over 3 is going to be a 60-degree reference angle. Okay, one more. Where is two pi over 3? Where's 2 pi over 3? What we got to keep in our brain. Adding. going past 180, counterclockwise, subtracting clockwise. Beautiful. Pi minus a pi over 3 means we are 60 degrees away from the x-axis in the second quadrant. What about 7 pi over 4? Where's 7 pi over 4? Where's 7 pi over 4? Where's 7 pi over 4? I don't care about its equivalent degree measurement. I care about its location and its reference angle. That's it. That's what I want. Ready, Murph? I don't care that it's equivalent to 325. I care that it's 8 pi over 4 or 2 pi minus pi over 4 to get 7 pi over 4. Go all the way around to 2 pi, which is 8 pi over 4. Subtract a pi over 4. You are in the fourth quadrant, making a reference angle of 45 degrees. Now, what if you did pi? You'd have to do pi plus 3 pi over 4. You could do that, but you'd have to add 45, 1, 2, 3 times. There are other ways to get the locations, but like, keep it easy. You should be one away. Reference, okay? All right, let's blow your minds a little bit. Oh, shoot. Go to the next page. Go to the next page. All right. What's the sine of pi over 3? Ready? This is easy. This is easy. Let's start understanding what is the circle. It's not just any random circle. This is the unit circle. What's so special about a unit circle? Tell your neighbors. What's so special about a unit circle? The radius is 1. Very good. All right. Good. Here's step 1. Where's pi over 3? Where's pi over 3? Go. Where's pi over 3? And what did I say is important? The reference angle. So please, where is the terminal side and what is its reference angle? Okay, good. Boom. 60 degrees away from the angle 0, initial side, terminal side. What we're about to do is combine what we did with day 1 to what we just did right here. Because this is a circle with radius 1, I know this length. What's that length? What's that length? This is the length of 1. Okay. I'm going to start up here where my terminal side intersects with my unit circle. And I'm going to, remember kind of how we were drawing triangles with X, Y, and R? Here it comes. Draw a line going down to the x-axis, never to the y-axis. Always reference to the x-axis, draw the triangle. And all of a sudden, what do you see? A 30, 60, 90 triangle with a hypotenuse of 1. We've just put triangles into circles. We just connected day 1 to day 2 with the radians in the circle. Okay. Now, what are the side lengths of this leg and this leg? Write them down.
Okay, you have a problem when you
What are the side lengths of this leg and this leg if that hypotenuse is 1? Okay. Turns out, guys, the sine of pi over 3 has got to be the same as the sine of 60 degrees. You guys answered what the sine of 60 degrees is last class because you knew the 30, 60, 90 triangle. Well, now you know what the sine of pi over 3 is. What's the sine of pi over 3? What's the sine of pi over 3? Opposite over hypotenuse. What's the sine of pi over 3? Root 3 over 2. Step 1. Radian. Where is it? What's the reference? Step 2. Your triangle with the radius of 1. Don't confuse radians and radiuses, even though they're very similar. What's the radian measurement? Where's the angle? Use the reference angle to help you. Step 2, you have a triangle. Draw it with your radius equal to 1. Step 3, your friend Sokoto is always there for you. He'll always be there. What's the cosine of pi over 4? Let's do it together. Step 1, the radian pi over 4. Where is it? Okay, go. Pi over 4. Where is it? Where is it? Where's pi over 4? You got to remember. Pi over 6, 30. Pi over 4, 45. Pi over 3, 60. Because you know 2 pi is 360, and you know pi is 180. You can take pi, which equals 180, and start dividing it. Divide it by 6. 180 divided by 6, 30. Divided by 4, 45. Divided by 3, 60. Okay, boom. Step 2, understanding that the radius is 1 and understanding your reference angle. Draw your triangle with your x-axis. Step 3. What are the side lengths? SOHCAHTOA. Root 2 over 2, root 2 over 2. What's the cosine of pi over 4? Root 2 over 2. What's the tangent of pi over 6? What's the tangent of pi over 6? Step 1, radian. Step 2, triangle. Step 3, SOHCAHTOA. I'm going to keep going a little bit to talk about arc length. You guys can head out. This is kind of like obvious. I don't think it needs to be in the notes, but it's good. If you want to know the explanation, I explain it as well in the homework video. Hope you understood radians. You are well on your way for the rest of this unit, if you do. All right. Triangles are proportional. Circles are proportional too. What does that mean? The arc length of a circle divided by its circumference is equivalent to the arc length of another circle divided by its circumference. We defined for a unit circle that the arc length is really like the radian measurement. The circumference is 2 times pi times 1. Well, if we have another circle with a radius r, then its length, I don't know, and its circumference is 2 pi r. What happens? Well, these 2 pi's really just go away. And you realize that another definition, and this is Huffaker's definition in that first page that he put in the notes. It's a good definition. I don't really use it. Another definition for a radius is an arc length divided by the radius. So this equates to the arc length equals a radius times the radian measurement. Here's an example of a question. You have a radian measurement of 1.5. You have a radius of a bigger circle of 4. What is this arc length BC? Well, this is your key. Your radian measurement, 1.5, is equivalent to your arc length divided by the radius. The whole 2 pi in the formula for circumferences disappear, and you get that your arc length is just 4 times 1.5. It really becomes something obvious. You can just multiply this by that. It's kind of like your multiplier in triangles becoming a multiplier for circles. Arc length for a unit circle times an m becomes an arc length of a different size circle. Okay, so we get whatever this is, 6. The extra examples, this is a good one. It's just another extension of what we've already done, just looked at differently. What is the slope of the terminal ray of the angle? If you have an angle in standard position with the theta equal to pi over 3, what is the slope of the terminal ray? Well, kind of just like start with what we kind of know, with what I kind of told you to do. Start with the radian measurement, then draw your triangle, and go from there. So pi over 3, where's it located, and what's the reference angle? Good, so here it is, 60 degrees away from 0. Step 2, draw your triangle. Think about the unit circle, the radius is 1. What is this? What is that? What do you guys know about slopes? Exactly. This slope is what we're trying to find. How do you find slopes? Rise over run. Rise over run. Y over x. It ends up being the tangent of the value. Rise is the y distance. Run is the x distance. What's the answer to the next one? You got those. That's it. The rise and the run are the same. The slope is 1.
Okay, I'm confused. I'm sorry.
Which part? Pi over 4. Do you know where pi over 4 is located? Come on.
That would be 45 degrees.
Great. Do you know the side length measurements of a 45, 45, 90 triangle with a hypotenuse of 1?
Oh, that's 2 squared over 2.
Yeah, square root 2 over 2. Square root 2 over 2. Cool. Now, if a slope is a rise over run, your rise is this distance. Your run is this distance.
Right.
Rise over run. Root 2 over 2 divided by root 2 over 2. 1.
Okay. It's because it multiplies by 1.
That's just like divide something by itself to get 1.
Right. Okay.
This last one is a little interesting because they're giving you the coordinates, but what we will be able to do pretty quickly is like understand if this is coordinates that intersect with this circle, and the coordinates are 3/10 and root 91/10. Those coordinates are x length and y length. You can create a triangle with coordinates. 3/10 is this length of a triangle. Root 91/10 is this length of the triangle. If you have a coordinate pair, you actually have a triangle if you want it. An x, a y, you can find your r if you wanted to using the Pythagorean theorem, or that's good. The question is, what is the slope of this line segment? Well, rise is the y over run. Root 91/3. Okay? And that's it. Radians. Boom, we understand radians. Then, understanding that the unit circle is a circle radius 1, we place triangles inside the circles, and that will help us for trigs of radians, which is really where we're going.